Thank you for this invitation. And we're already experiencing climate change today. So hopefully all of you are thinking, when was the last time I urinated? Because that is the hypothesis today. Increasing temperature leads to increased transdermal water loss, and that leads to a decrease in urine volume. So it's certainly conceivable that climate change could lead to a change in kidney stones. Dr. Trinchieri this morning talked about that possibility, and I'm going to suggest that it's more complicated than we might think. So here is Greg Tashian's data on kidney stones and season, and not surprisingly, we know that kidney stones occur more frequently as the temperature goes up. So here in North America, and I'm sure it's true in Europe as well, there's an increase in temperature and an increase in emergency room visits for kidney stones. So that's not particularly surprising. We took some of the data that was actually collected in the 1980s, and we split this up into men and women. And these data had not been done before. Robert Fercari, working with me, looked at men and women. Interestingly, and we know that men have more kidney stones than women, and although the ratio continues to go down, somehow women are catching up. Sorry, this is very sensitive. And you can see on the top line that on the x-axis, as the ambient temperature of 47 of 50 states in the United States goes up, the number of kidney stones on the y-axis increases as well. Men are in the line at the top, women at the bottom, and you can see that for both men and women there's a positive slope. But the slope is more significant for men than it is for women. Although the women have an increased rate as the temperature goes up, they do not have as great a slope. So the possibility that men are somehow more affected by temperature than women is an interesting one. And these are some ancient data from Fred Koh's University of Chicago clinic that looks at urine volume on the y-axis from January through December. And the top line is men, the bottom line is women. And you can see that what happens is that urine volume goes down for men in the summertime, but not for women. And Fred wrote, the best hypothesis is that women lose sodium via sweating and replace their losses with water, whereas men do not replace water losses as completely. That's an interesting idea, and it suggests to me that just as there are genes in the hypothalamus that regulate food intake and caloric intake and obesity, is there potentially a gene that regulates the osmostat and our responses to fluid? Why would it be that men have a decrease in urine volume and women don't? But there are other possibilities regarding kidney function and urine volume that we could talk about. But you know how it's going. This is average temperature change as put forth by the Intergovernmental Panel on Climate Change. And these data suggest that if we did everything we could to prevent progression of climate change, we'd have a line in blue with a minimal change in temperature, of course, but the way it's going is red. And so by the year 2100, I won't be in practice anymore, but there's going to be a lot of kidney stones at that time. Peggy Pearl's data, Peggy and Yair Lotan, urologists, combined with Burkowski, the first author, he's a geoscientist, and they projected how climate change would lead to increased prevalence of kidney stones in the United States. So in the year 2000, the south part of the United States in yellow had a higher rate than anywhere north. That was mostly probably related to temperature, although people have suggested more sunshine, more vitamin D, different diet, maybe different genetics. I think the most likely hypothesis was temperature. And if things go the way they're going, in 2095, New York City, and I hope you all know where that is in red. Then the rates in 2095 will be the rates that are currently present in the south part of the United States. Every 1 degree change in temperature will increase stone risk by about 4.2%. These are Peggy's data. But I'll point out that we know that kidney stones have increased in prevalence to date over the last 30 years. Kiriaki's data, Chuck Scales' data show that kidney stones are increasing in prevalence. And we know that that happened at the end of the 20th century. when global warming could only change the temperature of the Earth by about 1 degree Celsius. So I thought that seemed very unlikely to be an important cause of kidney stones. I'm not a climate change denialist, but we thought of there may be another hypothesis. And then I learned about urban heat islands. So the urban heat island, we're in the middle of it right now in Athens. The urban heat island is a place where the temperature is significantly different. So although the temperature of the Earth perhaps has changed by 1 degree, the temperature of the city, and here downtown right in the middle, and the rural areas out on the extremes, the difference is perhaps 5, 6, 7 degrees Celsius difference between the hottest place, the city, and the rural environment. The urban heat island is a couple of different things that I've learned about. The urban environment soaks up heat, and the asphalt and concrete radiate it outward at night. The rural areas soak up the heat and tend not to radiate it out. The rural areas have water, and as the water evaporates, that takes away heat as well. So here is a picture of New York City on a hot day in 2006 in the summertime. The graph on the picture on the left is color-coded for temperature. So right down the center of Manhattan, where I work, there's a dark stripe. That dark stripe is significantly cooler, and of course, that's Central Park. The graph on the right is color-coded for vegetation. And you can see that there's a green stripe down the middle of New York City, and that is Central Park. So the areas that are vegetated are significantly cooler. This satellite map of Baltimore is color-coded differently. On the left, the red is architectural density, while on the right, the temperature is, again, it's white hot in the center of Baltimore, correlating with urban architectural density. So these are pictures of what urban heat islands look like. And the really fascinating idea is this is related to what I think about with hypertension in chronic kidney disease. Patients with chronic kidney disease are non-dippers. They go to sleep and their blood pressure fails to go down. And it may be that that failure to go down is part of the cardiovascular risk of hypertension. What happens in cities is very similar. There's a non-dipping of temperature. The temperature doesn't go down as much. So the rural area has a decrease in temperature at nighttime, and the urban area fails to go down quite as much. So the delta, the line at the bottom, shows the difference in temperature between the rural area and the urban area. And these amazing data have been just published last year in the New York Times. And the scientists who contributed these data really have something interesting to show you. So this is basically the fact that urban heat islands is a phenomenon of nighttime. It's the non-dipping idea. So here in a hot place, Phoenix, Arizona, you can see that in the 1960s, 5% of nights were abnormally hot and 5% of nights were abnormally cold. Move this up into the beginning of the 21st century, and it's a completely different story. 49% of nights were abnormally hot. This is really the urban heat island phenomenon, is a nighttime phenomenon. I've always thought that people make kidney stones while they're sleeping. They drink less when they go to sleep, and they fail to drink during the course of the nighttime. And some of us used to tell patients to drink more water before they went to sleep. This really suggests that the temperature at nighttime is a completely different story. So in 2021, many of the states in the United States experienced their hottest summer nights since 1895, when recorded data really began in this regard. And this really was a kind of a graph that I found. This is from the United Nations, and it basically suggests that this whole thing is important because in the orange line, the number of people living in cities, this is the global graph. In green, the number of people living in rural communities. So for the first time, sometime in the 21st century, these lines crossed. There are now more people living in the cities than living in the rural area. And certainly that's true in Greece and Athens, as you know. So urbanization, the increase in the size of urban populations, migrations to cities, cities where the jobs are, where the money is, and the like, and people reproducing, of course. The United Nations calls this the greatest human migration in history. So we wrote this hypothesis paper, Medical Hypotheses, and you know how you get into medical hypotheses. You get rejected by the Lancet, the New England Journal, the Annals of Internal Medicine, then you get into medical hypotheses. When the reviewers say, you don't have the data. Well, if you want me to do a randomized trial where I move 50,000 people in rural Greece into Athens, I'm not going to be able to do that study. But the idea that urban areas are hotter, that hotter areas are associated with kidney stones, there are no questions about that. So I think we have the data, we just didn't do a randomized trial. So we keep working to try to demonstrate that people in cities have more kidney stones than people in rural areas. But of course, the problem here, as my epidemiology friends always point out to me, is that when you move to the city, you have a change in your diet, and your activity, and your exercise, and your income, and the food that you eat as well. So it's not necessarily so easy to demonstrate that this is true. There are other things about kidney disease that are going to be affected. So there's lots of literature like this. This is an article from 2017 suggesting that this is not just about kidney stones. Of course, there's more evidence of AKI, end-stage kidney disease, vector-borne diseases. There's going to be this incredible increase in mosquito populations and malaria, and that's going to affect kidneys. Missed hemodialysis is something that happens in Ukraine right now as a result of war. It happens when there are climate disasters as well, and chronic kidney disease is going up. We can certainly think about the pathogenesis of heat stroke, which has occurred in France, in Chicago, in a variety of cities, with many contributions of hyperthermia leading to salt and water changes and the like. So finally, I'll just point out, if you haven't heard about what was called Mesoamerican nephropathy, is now often called Ckdu, chronic kidney disease of uncertain etiology. These are epidemics of chronic kidney disease leading to end-stage kidney disease, very commonly involving people exposed to extreme heat. First in Mesoamerica, Nicaragua and Guatemala, now has been identified in a variety of other locations. Primarily young men. Generally, they're doing hard work in hot environments. No one has been able to prove that this is kidney stone related or even crystal related, though Rick Johnson, one of the world's experts on uric acid, thinks that that is probably the case. Most of these people have had kidney biopsies that do not disclose a specific disease. They have some tubulointerstitial nephropathy and some glomerulosclerosis. But the death toll in Central America is thought to be at least 20,000 people or more. And basically here in a paper that I found last week from the University of Athens, if a multidisciplinary approach arises, then the dramatic effects of climate and environmental changes may be ameliorated. It's happening right here as we sit in Athens today, but I would be surprised if a multidisciplinary approach is going to happen and be successful. Thank you.